Question 20. N is an integer, and that just means a whole number, such that 3n plus 2 is less than or equal to 14, and 6n over n squared plus 5 is greater than 1. Find all the possible values of n. This isn't as complicated as it seems. We simply have to solve this inequality and this inequality, and then see which values of n satisfy both inequalities. So I'll start off with the linear inequality because it's a little bit easier to do. And to solve this for n, well, I'm going to take 2 from both sides. So 3n is less than 12. Divide by 3, and n is less than or equal to any integer below 4. And that's picked me up one of the 5 marks. The other equation, 6n over n squared plus 5 is greater than 1. It's a little bit harder to solve, but my first step will be to multiply by n squared plus 5 so that I get rid of the fraction. Then I need to expand the bracket, so 6n is greater than n squared plus 5, because it's just one lot of that. To solve this, I'm going to have to factorize it, so I'm going to take away the n squared and the 5 from both sides, and I'm going to have minus n squared plus 6n take 5 is greater than 0. You can solve this from here, but it's a bit of a pain with the minus n squared, so I'm going to multiply the whole expression by minus 1 and get n squared minus 6n plus 5 is less than 0. Notice the inequality changes direction when you multiply by a negative number or divide. There's my second mark. This should now factorize, and I'm left with n minus 5, n minus 1 is less than 0, and there's my third mark. Now, from here, the best strategy is just to draw a little graph to see which parts of the integer number line are your answers. So if n minus 5, n minus 1 is less than 0, this curve will go through 1 and 5 as they're the roots. So it's just a sketch to help me out. And also the intercept is plus 5, so there's plus 5. So this curve is going to look a little bit like that. And what I'm interested in are the bits that are less than 0. So it's this bit here. So my fourth mark is for saying that 1 is less than n, which is less than 5. So to solve this equation, I have 1 is less than n when n is less than 5. To get the final mark, I just need to compare my two answers, so this one here and this one here, and the values of n that satisfy both are 4, 3, and 2. And there is my fifth mark. Well done if you've gone through the whole exam paper with me, and don't forget, please subscribe.